Dear students, yesterday we have discussed the 4-membered rings. Today we are going to discuss the 5-membered rings. In general, a reaction that forms a stainless or a near stainless 5-membered ring occurs more readily than corresponding intermolecular reaction because the entropy of activation is much more favorable. For example, hydroxy acid 29 cannot usually be isolated. The anion 30 is stable, but the neutralization causes the instant cyclization of lactones 31. Tactics for the synthesis of 5-membered ring heterocyclics are to disconnect both the CX bond and to identify the electrophile carbon fragment needed to add to the nucleophile heteroatom. Cyclic sulfide 32 requires the cis dihalide 33, this halide and this halide, which may be obtained from the cis butane diol this. So the retrosynthetic analysis is we are having the thiol carbon sulfur breakage will give XX on the terminal carbon atom, and this CX terminal breakage will give the diols. So this diol is treated with PCl5 in synthesis, and we are having the ClCl, and with Na2S we are getting the target molecule 32. With 2 heteroatom in the ring, it is often easiest to identify and readily available fragment, as we see in the table, containing both the heteroatoms and disconnect it from the suitable electrophilic fragments. The table shows the some available reagents containing the 2 heteroatom, hydroxylamine NH2 and OH, hydrazine 2NH2 and urea 2NH2, thiourea 2NH2, glycol 2OH, ethanol amine 1NH2, 1OH, diethylene amine and diazoethane, phenylhydrazine, orthophenylene diamine, catechol, acetamide and thioamide. Consider synthesis of Pyron 35. An obvious point of disconnection is the nitrogen carbonyl bond. It results in the formation of 36, since this type of the bond readily formed by the reaction of a NH containing group and acid derivative COX, where X is a good leaving group. The next disconnection might made at the C double bond N, since the NH2 and C double bond O carbonyl group reacts together readily. Available compound is this 1 and 2 nitrogen heterocyclic heteroatoms are present in a 5-membered ring, so it will be cleaved here, and we have NHPHN and COX here. The next disconnection might made at the C double bond N, since the NH2 and carbonyl group reacts together readily. Available compounds are this. Now recognize the phenylhydrazine and the derivative of acetoacetic ester. In phenylhydrazine, the nitrogen atom in the NH2 group is more strongly nucleophile than that in the NH group, since the unshared electron pair on the later nitrogen takes part in a delocalized system with an aromatic ring. The NH2 group will therefore be the first to react, and now if the leaving group X in the acetoacetic derivative is chloride, then since acid chloride are more reactive than ketone towards the nucleophile, the first reaction would occurs with the wrong chemoselectivity. However, the esters are less active than ketones towards the nucleophile, so that the desired sequence of the reaction would occur if X were OET, and the acetoacetic ester is therefore a suitable strongly starting material, and the sequence of reaction is like this. We are having the keto ester, phenylhydrazine. So phenylhydrazine will be added here, water molecule will be lost, and with the loss of ethanol molecule we are having this cyclic compound. Sometimes the disconnection of carbon-carbon bond may help. Example, CX disconnection on 37 and gives a starting material 38, which difficult to assess. However, 1,3 dicarbonyl disconnection leads to 39, which allows the more helpful carbon sulfur disconnection. You can see here retrosynthetic analysis. we are having the thiol having the keto group and ester group. This CX will be cleaved and we are having the Cl, C double bond O, COET and double bond O. In the synthesis, the two carbon-carbon disconnection here, this compound, and then 1,3 dicarbonyl compound, this compound, and this on the A giving the bromo ester and the eno ester, and this is combined in the A path, this is A path, and in the B path it is having the HS here and en ester. The disconnection B, this was chosen by the Woodward because the thioacetic ester 40 is available. So thioacetic ester is combining with the alkene ester in the presence of pyridine, giving the 39 will giving the target molecule 37. Next is 1,3 dipolar cycloaddition reaction. One special method for the 5-membered ring is 1,3 dipolar cycloaddition reaction. Example 41. Diazomethane is adding the addition on the double bond and giving a cyclic hetoatom. Conjugated alkene reacts best as the deals add a reaction so that the hetoatom and the ester group in 42 suggests the 1,3 dipolar disconnection. So 42 we are having the nitrogen and oxygen, and here the ester group, so cleavage will take place at the ester group. So in 1,3 dicarbonyl group it is giving the 43 and double bond ester. So 1,3 dipole 43 is nitron. This is nitron made from a cyclic amine by the sequence of oxidation, elimination and another oxidation. The cycloaddition gives only the isomer 42 required that the trans stereochemistry of the unsaturated ester must be preserved. So in the synthesis you are having the nitrogen ester, it is giving the nitron at 150 degrees centigrade, it is converting into the hydroxy pyrrole, and in the mercuric oxide giving the 43 and giving the target molecule 42. This is our target molecule. So this way the 5-membered rings can be prepared by taking the 1,3 dipolar cycloaddition reaction. Thank you. In the next lecture we will deal with the 6-membered ring. Thank you.